Hello everyone, welcome to Brain Blitz Audios. So today in this episode of KEEM Prep, we are going to be looking at some questions which were asked in KEEM 2016. So KEEM basically stands for Kerala Engineering, Architecture and Medical. So it's basically an entrance examination held in India. And you get questions from mathematics, physics, chemistry, and other subjects. So today we're going to be looking at some of the main subjects and how to prepare for them in detail. So if you want to prepare for these types of exams in the last minute, then the best way to do that is to check out the previous year questions so that you can have an idea of what kinds of questions come and what are the portions that you need to take care of. So by taking this obvious step, we've decided to help out and check out some content of KEEM. So now let's look at our first question. This is from mathematics. Let f of x be equal to x cubed and g of x be equal to 3 raised to x. The values of a such that g of f of a equals f of g of a are 0 to 2, 1 to 3, 0 plus minus 3, 1 plus minus 2, 0 plus minus root 3. So how do we solve this question? Now we know that the condition here is g of f of a equals f of g of a. And that means we will use BODMAS, which means we figure out the relation of the bracket first, whatever is inside the bracket first, and then we go on to outside the bracket. So in this particular scenario, g of f of a equals f of g of a. So that's our condition. So f of a will be a raised to 3. So it's basically a cubed. G of a cubed will be equal to f of g of x is 3 raised to x, so that is 3 raised to a. Now g of x is 3 raised to x, so that means 3 raised to a cubed equals 3a the whole cube. Now 3a the whole cube can be written as 3 raised to 3a, and the left hand side will be 3 raised to a cube. So now what we're going to do is we're going to equate the exponents. So when we equate the exponents, you'll get a cubed as equal to 3 times a, which means a cubed minus 3a equals 0. Now that means a times a squared minus 3 equals 0. So you have two options. So you have a equals 0, or you have a squared minus 3 equals 0. So this would mean that a squared equals 3, which means a equals plus or minus under root of 3. So therefore, the correct option among the following is option E, 0, comma, plus or minus root 3. So option E contains the correct values of a, such as the composition of g and f is equal to the composition of f and g. So g of f of a is equal to f of g of a is true when a equals 0, plus root 3, or minus root 3. Let's look at another question of mathematics. If f of x plus 1 divided by 2x minus 1 equals 2x, where x belongs to the set of natural numbers, then the value of f of 2 is equal to option A 1, option B 4, option C 3, option D 2, option E 5. So how do we solve this question? The original equation is f of x plus 1 divided by 2x minus 1 equals 2 times x. And what we're asked to find out is the value of f of 2. So basically, we are equating x plus 1 divided by 2x minus 1 equals 2 for this particular scenario. So once we find x, it's easy to find out the value because the value of that function is 2 times x. So x plus 1 divided by 2x minus 1 equals 2. That means x plus 1 equals 2 times 2x minus 1, which equals 4x minus 2. So therefore, let's take the x on the left-hand side to the right-hand side. Minus 2 becomes plus 2 in the left-hand side. So 1 plus 2, that is 3, equals 4x minus x, which is 3x. So therefore, x equals 1. So now we know that x equals 1. So f of 2 will be equal to 2 times x, which in this particular case is 2 times 1, which is equal to 2. So therefore, the correct option is option D, 2. Now let's look at some questions of chemistry. The Finkelstein reaction is an example of aliphatic nucleophilic substitution, aliphatic electrophilic substitution, aromatic electrophilic substitution, aliphatic free radical substitution, aliphatic elimination. So which of these is the correct option? Well, in the Finkelstein reaction, the iodine atom, which is rich with electrons, is added to the organic compound, the hydrocarbon, in order to form iodoalkanes, and iodoalkenes and iodoalkynes. So how do we find out which of these is the correct option? The best way to do it is to get out examples for these reactions. So we have option E, aliphatic elimination reaction. This is found in dehalogenation of alkyl halides with NaOCH3. So therefore, option E, aliphatic elimination reaction, is the wrong answer. Next, we have aliphatic free radical substitution. So this occurs in substitution reactions such as the chlorination of methane in sunlight. So the process that gives us chloroform, CHCl3, is aliphatic free radical substitution. So basically, chlorine, Cl2, is converted into a free radical in the presence of sunlight, and this free radical replaces the hydrogen in hydrocarbons. So therefore, option D is incorrect. Option C, aromatic electrophilic substitution reaction. So here we are dealing with, number 1, aromatic compounds, and number 2, we're dealing with electrophiles. So electrophiles are basically compounds which are electron deficient because they are attracted to electrons. Nucleophiles are groups which are electron rich. That means they have a lot of electrons and they're looking forward to finding some positive charge. An example for aromatic electrophilic substitution reaction is the bromination of benzene. So what happens here is that the electron deficient bromine atom decides to take the place of hydrogen, and therefore substitution occurs in an aromatic group. So option C is incorrect. Finkelstein reaction occurs in an aliphatic group. So that means you have aliphatic electrophilic substitution, aliphatic nucleophilic substitution. So over here you have in option B, the correct answer will be nitrosation, because in nitrization the nitrogen gets added to organic compounds, which gives us nitroso compounds from organic compounds. So therefore, option B is incorrect. The correct answer is option A, aliphatic nucleophilic substitution reaction. So the Finkelstein reaction is an example of an aliphatic nucleophilic substitution reaction. Now, consider the following haloalkanes. These are 1-bromobutane, 2-bromo-2-methylpropane, 2-bromobutane. The boiling points of the above isomeric haloalkanes decrease in the order. Is it 1 less than 1 greater than 2 greater than 3, 3 greater than 2 greater than 1, 2 greater than 3 greater than 1, and you have 2 greater than 1 greater than 3, and 1 greater than 3 greater than 2. So note that all of these compounds, all of these haloalkanes, they are isomeric. So that means they are structural or other isomers of each other. So let's first draw out their structures. First, we have 1-bromobutane. So CH3, CH2, 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 Br. And you have 2-bromo-2-methylpropane, which is CH3, C, CH3, Br, and CH3. And finally, you have 2-bromobutane, which is CH3, CH2, and then CH, and then you have a Br, and then CH3. So therefore, you have the structures for all of these isomeric haloalkanes. Now, we're looking at boiling points. We need to find out the relation between the boiling points of these three isomeric haloalkanes. So, since we're dealing with isomeric haloalkanes, we can use the property that the boiling points of isomeric haloalkanes decreases with the increase in branching. So basically, when you have structural isomers, you have a straight chain and then you have branches as well to form a different structure. So therefore, what we can see is that the boiling point decreases with the increase in branching. So as the branching goes from lower to higher, the boiling point goes from highest to lowest. So as you can see, the lowest amount of branching occurs in 1-bromobutane, because 1-bromobutane is basically a straight chain. After that, you have, 2-bromobutane, because in 2-bromobutane, the Br goes from the first carbon to the second carbon. So it essentially, makes a CH3 branch off from one end of the last carbon. So that means 3 will be slightly branched than 1, but it's not as branched as 2, so therefore it has intermediate boiling point, and 2-bromo-2-methylpropane has the highest amount of boiling point. So therefore option E, 1 greater than 3 greater than 2, is the correct answer, because 1 is the least branched and 2 is the most branched. It's highly branched, while 1 is not branched at all. Now let's look at some questions of physics. The circuit element to which Ohm's law is applicable is junction diode, Zener diode, resistor, transistor, and photodiode. Now, when we're studying Ohm's law in current electricity, we know that Ohm's law is not universal. It is found in a lot of materials, but it's not universal. And we have also studied that Ohm's law is not applicable to semiconductors. The reason being that in semiconductors, the ratio between the voltage across the semiconductor and the current passing through the semiconductor changes. It is variable. It is not constant. Whereas Ohm's law states that V is proportional to I, so that proportion has to stay constant. So we have 5 options here: junction diode, Zener diode, resistor, transistor, photodiode. Now, it's easy to eliminate the options around here because junction diode is, so all kinds of diodes are basically semiconductor diodes. What we've studied. So junction diode is a semiconductor diode. Basically, it has a p-type semiconductor at one end and an n-type semiconductor at the other end. Zener diode is again a type of diode that's operating in reverse bias. So that means it is again exempted from Ohm's law. It's not following Ohm's law. So A and B are incorrect. Transistor is a semiconductor diode with 3 terminals. So that means you have NPN or PNP. That means option D is incorrect. Photodiode is again another diode which works in reverse bias. That means option E is also incorrect. The correct answer is option C, resistor. So a resistor is not made out of semiconductor material. It is not a diode. So therefore, Ohm's law is applicable to a resistor since it's not a semiconductor. So therefore, option C, resistor, is the correct answer. Now, let's look at the last question for this particular episode. Nichrome is used as electric heating element because of its A, negative temperature coefficient of resistance, B, strong dependence of resistivity with temperature, C, low melting point, D, weak dependence of resistivity with temperature, E, semiconducting nature. So over here, the topic that we're dealing with is the dependence of resistivity and resistance to temperature. So in general cases, resistance is proportional to the temperature. So that means the resistivity of an element the resistivity of a material at a temperature T is equal to the original resistivity at room temperature, and then 1 plus alpha times T minus T naught. So this is the formula that dictates the increase in resistivity with respect to the temperature. Now, this particular ratio is that the resistivity at the temperature T with respect to its original resistivity. This varies with material. So depending on the material that you use, the ratio can vary. So the first is for conductors. So conductors made out of one metal, such as, copper wires, aluminum wires, etc. Now these have a strong dependence of resistivity with temperature. That means option B is incorrect because these cannot be used as an electrical heating element. Because if they're used as such, the increase in temperature also means that there is an increase in resistivity, which results in terrible loss of power. Now, low melting point is a characteristic of fuses. So nichrome is not a fuse, it's used as an electrical heating element. So fuses are wires which melt out faster with low melting point when you have an overload of current passing through them. And semiconducting nature, again, this applies to semiconductors, group 14 elements. So devices with group 14 elements which are doped with positive or negative impurities. So semiconducting nature, nichrome is not made out of group 14 elements. Nichrome is an alloy. Next, we have option A, negative temperature coefficient of resistance. So that is the second part. When you have semiconductors, you will notice that the resistivity at a particular temperature, as the temperature increases, the resistivity undergoes a gradual decline. So therefore, over here, it's a negative temperature coefficient. So for semiconductors, negative temperature coefficient, so option A is incorrect. The correct answer is option D, weak dependence of resistivity with temperature. This is the third type of material behavior to temperature. So materials such as alloys, like nichrome, constantan, etc., they have a weak dependence of resistivity with respect to temperature. So what this means is there is a nominal or minimal increase in resistivity even if you are increasing the temperature to very high levels. So therefore, option D is the correct answer for this question, because if you want to have an electrical heating element, then the material should have a weak dependence of resistivity with respect to temperature. Otherwise, as the temperature increases, the resistivity also increases. It makes it harder for the current to pass through the element, and that makes for a terrible loss of power. So that means that there will be terrible loss of power. So option D is the correct option for this question, which was asked in 2016. That concludes this episode of KEEM Prep. We hope you found this episode interesting. If you want to access more of our videos, don't forget to subscribe to our channel, which is Brain Blitz Audios. If you want to have access to the playlist of KEEM, don't forget to hit the playlists link in the description box down below. You can also get updates about our latest content by hitting the bell icon, which is present below the video. If you want to give your opinion about something that was done here, or your opinions on what content we should create, then don't forget to comment, to drop us a line in the comment section down below. So until the next episode, take care, stay safe, bye-bye for now.